Okay, in number 26 and 27, we're looking for the absolute value. The absolute value. And it's the absolute value of 6 minus 2i, a minus bi. So what we're looking at and what we can pull for and glean from this is that a is 6 and b is negative 2. And in our imaginary and real axis or coordinate plane, our imaginary coordinate plane, this is going to be the ordered pair 6, negative 2. What we might consider xy. Now, I want to pull this out and see if I can very quickly show you what this is going to be. This is my real axis along what used to be at my x, and this is my imaginary axis. Y became the imaginary axis. That's one easy way to remember it. And if this is my ordered pair, I'm going to go positive 6 for my real, down 2 right here, and it's not drawn to scale, but down 2 for my imaginary, because this is my imaginary. So if I were to plot this point, I've come over a positive 6, and I've come down a negative 2. Now, if we go back and remember what absolute value is. Absolute value is, by definition, how far a point or a number is from 0. Well, in this case, the origin is 0, so what I'm looking at is this segment right here. How far is that? That distance? Well, I'm looking right here and I say, you know what? I formed a right triangle, and we learned from geometry that if we have a right triangle, we can use the Pythagorean theorem and say a squared plus b squared equals 2c squared. And that's where I'm gleaning these points here. So I can say a squared plus b squared is equal to c squared. C is this distance to the origin to 0, which is by definition absolute value. So when I solve this, I have 36 plus 4 is equal to c squared. 36 plus 4 is 40 is equal to c squared. To undo a squared, you take the square root of both sides. This breaks down into 4 times 10, which is 2 square roots of 10, is equal to c. Now, before we talked about plus or minus, we're talking absolute value, is the distance. Absolute value is only going to be the positive value or the positive measure for c. So the absolute value from this ordered pair is going to be 2 square roots of 10. Now, just looking at number 27, just looking at that problem, knowing that a is negative 5 and b is 4. A is negative 5 and b is 4. A plus bi. I'm just going to use the Pythagorean theorem. A squared plus b squared is equal to c squared. So I have 25 plus 16 is equal to c squared. When I add those together, I have 41 is equal to c squared. Then I'm going to take the square root of both sides, right here. You can hardly see that, but we will. And then I'm going to say c is equal to, I don't know the square root of 41, it's a prime number, so that would be my answer. The answer is simply the square root of 41. So when you're finding that absolute value, it takes you back to that imaginary coordinate plane, but it's just simply using the Pythagorean theorem with your a and your b. One of the last things we're going to do is rationalize the denominator. Remember that to rationalize the denominator means you want to eliminate any radicals that are in that denominator. Well, if I remember, you've got to go back and remember that I is equal to the square root of negative 1. I squared is negative 1, just to put them all out there, and I to the 4th is 1. But because this is a square root, I cannot have it in the denominator. So I'm going to multiply by its conjugate, just like I did before. And the conjugate here is 6 plus 9i. What I do to the bottom, I must do to the top. So I'm going to distribute and FOIL in the numerator and the denominator. When I distribute, I have 18 plus 27i, and I'm just distributing that 3 to both of those numbers. And then I'm going to FOIL in the bottom. First, outside, inside, last. So I have 6 times 6 is 36. 6 times 9i is a positive 54i. Negative 9 times 6 is negative 54i. And then negative 9 times positive 9 is a negative 81, and I can't forget that that is I squared. Now conjugates are going to cancel. Conjugates will cancel in the middle. And so what I have is 18 plus 27I over 36. And then this is minus 81 times negative 1. I squared is equal to negative 1 plus 81. So when I add up my denominator, 18 plus 27I over 7 down, 111, 117. However, when I look at all three of those numbers, I see that they are divisible by 3. So I can say 3 will go into 18 6 times, 3 will go into 27 9, and 3 will go into this 39. So when I write that final answer, my final answer would be 6 plus 9I over 39. However, I still see another common factor. So really it was probably divisible by 9. I didn't use a calculator. So 3 will go into 6 2 times, 3 will go into this 3, and 3 will go into this 13. I think that's going to be my final answer. So we have 2 plus 3I over 13. So take it all the way down until you can't reduce it anymore. So apparently I could reduce this by 9. 3 will go into 117 13 times. So just continue to reduce. Just know that all three of them have to be able to be simplified. So this is my final answer. Also, the numerator is a plus bi form. That's what you want. And you won't have any i's in the final answer in the denominator. All right, let's look at number 29. On number 29, I have a binomial in the numerator and the denominator. Still, I want to multiply by the conjugate of the denominator. And that would be 6 plus 8i. What you do to the bottom, you must do to the top. So what I'm going to do is FOIL each. So I'm going to FOIL this numerator. 4 times 6 is 24. 4 times 8 is 32i. Negative 2i times 6 is negative 12i. And negative 2i times 18i is negative 16i squared. By now, when you see I squared, it should really kind of jump out at you. In the denominator, 6 times 6 is 36. 6 times 8i is 48i. Negative 8 times 6 is negative 48i. And then negative 8i times 8i is negative 64i squared. Again, conjugates are going to cancel in the middle, and I'm going to combine my like terms. However, here, I see negative 16 times negative 1. And here, I see negative 64 times negative 1. My real parts, I'm going to add up in the numerator and the denominator. So let's kind of condense down just a little bit. So we have 24, and I have 32 minus 12, which is a positive 20i. That's combining those like terms. And then I have 36, let me come back up here, plus 16, and in the denominator down here I have plus 64. So I'm going to combine some terms here. 24 plus 16 is 40 plus 20i divided by 36 plus 64, which is 100. So if I look right here, 24 plus 16, I get my 40. And then 36 plus 64 in the denominator is 100. One of those little shortcuts is since everything ends in a 0, I could cancel and divide it by 10. Or everything is divisible by 20. However you want to reduce it. 20 will go into 40 2 times. 20 will go into 20 1 time. And 20 will go into 100 5. So I have 2 plus 1i over 5. And we don't put that 1, it's understood to be there. So 2 plus I over 5 would be that final answer here. Whew. There. Just kind of remember, just very quickly, that if you have the square root of a negative number, it should be pretty easy to see this is 11i. The square root of negative 169, that would be 13i. The square root of negative 4, that is 2i. The square root of negative 8, I know the square root of 8 is 2 square roots of 2. Because it's negative, it's 2i square roots of 2. The square root of 32, negative 32 would be 4i square roots of 2 because that's 16 times 2. Sometimes they're going to throw in like the square root of negative 20. That's going to be 2i square roots of 5. Then they'll say, okay, the square root of 24. Notice that it's not negative, so you're just simply breaking that down to 2 square roots of 6. If I have I to the 27th, what you would say is 4 will go into 27. How many times? It'll go in there 6, which is 24. 25, 26, 27. That leaves you I cubed. So that final answer is negative I. If I have I to the 35th, it will go in there 32 times. 32, 33, 34, 35. That again is I cubed. That would be negative I. If I have I to the 28th, the 28th, 4 will go in there evenly. That answer is automatically 1. And if I had I to the 10th, 4 will go into 10 2 times, which is 8, leaving I squared. We've used that a ton today. That would be negative 1. So if I'm looking at these i's, this would be negative I, 1, negative 1. Notice that it's not going to have an exponent. It's not going to have an exponent. Go back and study and make sure you can rationalize and know your additive inverse that I threw in there in the middle. Good luck.